All right. So I'm gonna hold off on questions on homework for now. Let me finish up, because what I assigned for homework, there may have been some questions because we didn't do enough of these examples. So let me do a couple of these. We're finishing off 7.4, and then we'll move into the next section. So the idea that we've been working with is we're trying to find all 6 trig function values if we're given some information. In this particular case, we're given what tangent of this particular angle theta is. We're told that it's 6, and then we're told that our theta is restricted between 90 degrees and 270 degrees. So what I suggest you try and do is first figure out what quadrant you're in, and then try and draw like a reference triangle, and then just use your definitions of the trig functions to figure out the rest. So I'm going to start out here by taking a look at the tangent. The fact that tangent is 6 means that tangent is positive, correct? And tangent can only be positive where? 1 and 3, right? Quadrant 1 and 3. So what I can do is I can eliminate quadrant 2 and quadrant 4 just using the fact that tangent is positive. Y'all with me on that? Yes? Then I can use the information that the angle has to be between 90 and 270. So that puts me between, let's see, 90 degrees is straight up and down, 270 is straight down. And so I've got to be somewhere in either the second or the third quadrant, correct? So I can scrap the first quadrant. Can't be over there. Does everyone follow the logic there? And once I'm in that quadrant, I can try and draw a triangle. Now keep in mind that with these triangles, it is possible to have negative sides, because the sides actually represent your x and y coordinates. So the fact that I'm told that the tangent of this angle is 6, I need to first rewrite this as a fraction. So I can rewrite it as 6 over 1. And remember that tangent is always equal to which coordinate divided by which coordinate? Is it x over r, y over r, x over y? What is it? Y over x. Tangent is always y over x. Do you all agree? Okay, so when I draw this triangle out here, I have a point somewhere out here. My y coordinate divided by my x coordinate should be 6 divided by 1. But what's wrong with me writing it like this? If I'm in that quadrant, what can you tell me about x and y? They both have to be negative. Do you all agree? Now the fact that it's positive 6, that actually makes sense, because if they're both negative, it's really a positive, right? So we need to kind of identify, I'm going to put a negative, I'm going to put it in red here, because we're looking and we're in the third quadrant, we're realizing that those two have to be negative, and that's why it turned out to be positive. Do y'all see how you have to catch that? In the first quadrant, that wouldn't have happened. If we would have been in the first quadrant, both would have been positive, and it would have been 6 and 1. They couldn't have been negative. But because we're in the third, they both have to be negative. Yes? Okay, so I'll label them over here. Our x-coordinate is -1. Our y-coordinate is -6. And of course, my triangle doesn't look like it's drawn correctly, right? Like this is, if I say that's 6 and that's 1, it doesn't look right, but that's okay. It doesn't matter. As long as we have it drawn, we're okay. So the only thing we're really missing then is r, right? Once we have r, we can do all the other trig functions. So to determine what r is, we use the fact that x squared plus y squared must equal r squared. X we said was -1. We're going to square that. Plus y we said was -6. We're going to square that. That'll give us r squared. And this is where you can tell that the sign isn't going to matter when we're getting r, because we square them. So -1 squared is 1. -6 squared is +36. And that gives us r squared. So what is r? Square root of 37. And I don't use negative, why? Why don't I do plus or minus here? R is always positive. Now, later on, if we're solving for x or something, we might actually have to take the negative. It just depends on what quadrant we're in. So in this case, though, because it's r, it's always positive, we have root 37. And now from this, we can go get all the other trig functions. We have x, y, and r. So let's just produce those real quick. Sine of this angle would be, what sine? What over what? Y over r. So it would be, y is -6, isn't it? R is root 37. Cosine is your x over r. Where am I getting those formulas, x over r and y over r? Right off this sheet, right? Sheet I gave you. Or you've memorized them, whichever way. Tangent theta, you should at least get that right on the test, right? Because that was given. And then cosecant theta is the reciprocal of sine. Secant theta is the reciprocal of cosine. And you should always get cotangent correct, right? Flipping over this one. So the reciprocal of 6 is 1/6. And we're done. Any questions? So look at the given information, narrow down what quadrant you're in. Once you're in that quadrant, determine, whatever values you're given, draw your triangle. Be careful with your signs. All right, let's do another one. This will be example 8. Okay, what if I tell you that cotangent of some angle theta is -2, and I tell you that your angle is between 3 pi over 2 and 2 pi? All right, the fact that cotangent is negative is the first piece of information I'm going to use. Now, cotangent being negative means that tangent has to be negative, right? Because tangent's the reciprocal of cotangent. So saying cotangent is negative is the same as saying that tangent is. So where is tangent negative? Y'all follow that? If you're looking at cotangent, you really just have to look at tangent because it's just flipped over. So what quadrant is tangent negative in? Where is it? The second and the fourth. The second and the fourth. Remember what was it? All students take calculus? All students take calculus. These are the quadrants where the trig functions were positive, right? So all of them are positive here. The only one that's positive here is sine. The only one that's positive here is tangent. The only one here that's positive is cosine. So where would cotangent or tangent be negative? It would be here, or it would be here. Y'all follow that? So I can eliminate which two quadrants? I can eliminate the first. I can eliminate the third. All right, now I'm told that my angle has to be between, oh, you know what? I wrote that down wrong. I meant to put on here, instead of 2 pi, I meant to put, what did I mean to put? Well, we'll just leave it. Because where's 3 pi over 2? Straight down. And where's 2 pi? Right, so that would have told us quadrant 4 to begin with. Oops. I didn't mean for it to narrow it down. I meant for it to go between, where did I mean it to go? I don't know. I didn't want it to narrow it down to one quadrant because then you don't need this at all, do you? Oh well, it is what it is. It's not that one, right? We've got to be from 3 pi over 2 to 2 pi. Okay, so real quick, in this quadrant, x is always going to be what? Positive, right? And y would always be negative. We agree? Okay, now I'm going to write down what cotangent is. Cotangent of an angle, theta, is always equal to the, what, divided by what? X over the y. Now, I need that to be equal to -2, don't I? And I can rewrite -2 in two ways, couldn't I? I could go -2 over 1, or I could go 2 over -1. So I'll write them both down. You tell me which one it is. Do y'all see that? There's two different ways to write down the number -2. Which one of these matches our picture here, being in the fourth quadrant? 2 over -1. Because we must have that the negative sign is on the y. Because in the fourth quadrant, we have to come down, right? And then the positive is to the right for 2, for x. Are we good with this? Okay. So this is the correct one. This is the one we should work with. And I'm just going to list out real quick here. That means that x is 2 and y is -1. Now let me draw my triangle over here. Again, it doesn't have to be a perfect triangle. My x is 2, that's this side, and my y is -1 is that other leg. Y'all agree with the picture? X is 2, y is -1. Now we still need to find r, don't we? So I know that x squared plus y squared is r squared. So 2 squared plus -1 squared equals r squared. So what's that, 5? And then take the square root. So square root of 5. And I don't care about the negative, right? So you can get all your other trig functions now. Sine of theta is y over r, -1 over root 5. Cosine theta is x over r, so 2 over root 5. And then tangent theta, how do I get tangent theta? How would you get tangent theta here? You could do y over x, couldn't you? Or you could just flip over what you had to begin with, right? This is cotangent, so flipping that's tangent. So you could write that as -1/2. Either way. And then you go get the other 3. I'm not going to do that, but you could, right? Just flip them all over. Any questions here? Okay, good. Okay, how about this one? Something a little bit different. What if I tell you sine of an angle is 0, and I tell you that the angle is obtuse? So let's start by trying to draw out where we might be. This whole thing with like all students take calculus, right? That whole thing. That tells you where the trig functions are what? Positive, right? Right now, I'm saying sine is 0. Is 0 a positive number? No. Is 0 a negative number? No. 0 is neither positive nor negative. So that sign being 0 does not tell us anything about the quadrant. Like we can't really use that quadrant thing there. Do y'all see that? Now I am telling you that the angle is obtuse. Obtuse means what? Greater than 90, right? Acute was less than 90, obtuse is greater than 90. So I can rule out which quadrant? The first one, right? In fact, obtuse means you could not be anywhere in the first quadrant or on the actual horizontal and vertical axis, right? Because if it was straight up, it would be 90 degrees, right? Let's just rule that out. Now, think about this. Sine, by definition, is what coordinate over what coordinate? Y over R? Do you all agree? And I need to know when that's going to be equal to what? When is Y over R equal to 0? So a very important little fact here. When you have a fraction, like Y over R equal to 0, when you're trying to figure out when it's equal to 0, the only time a fraction can ever be 0 is if the numerator is 0. Always, always, always. This is kind of a side note, okay? I'll make a little side note over here. If you ever have a fraction, A over B equal to 0, then I guarantee you that A must be 0. Now, why is it that that would be true? Okay, so B couldn't be 0 here. You'll have division by 0, right? How about this? If this is an equation, can I multiply both sides by B? Could I? Could I come in here? If I start with this and I say, hey, when is this fraction equal to 0? Can I multiply B over here and B over here? Yes? When I multiply B on the left, the B's cancel. When I multiply B on the right, 0 times B is 0. So what you wind up getting is A is 0. And you could do that for any fraction, forever, all the time, without fail. So since you can always do that, I'm looking at this right here and I'm saying, hey, when is this fraction equal to 0? What does that force us to have then? I need Y over R to be equal to 0, which means that what must be 0 then? Y. Okay, Y has to be 0. Tell me where I am when Y is 0. On the x-axis, right? On the x-axis, do you agree that your Y coordinate is 0? Now, I can't be over there, though, to the right. I have to be over here to the left, don't I? So what I need to do is I need to just pick a point, any point. I don't care where it is. And I'm going to call that point, let's see, we know the Y coordinate is 0, don't we? What's the X coordinate? It can be anything, can it? All I know, though, is that it's a negative number. Do you agree? So how about we put negative X? Do y'all follow that? Pardon me? Why does it have to be right here and not up here or down here? Is that because if Y is 0, right? Imagine I tell you to plot a point, okay? But I tell you that the Y coordinate has to be 0. That means you're not allowed to move up or down, right? You have to stay flat. You can move left and right wherever you want, but your Y has to stay at 0. Does that answer? Yes? Okay. But the fact that we're over on the left side is why my X coordinate would need to be negative. Yeah? Okay, now, very important here. Very, very important little step here. We know what Y is, right? We don't really know what X is, other than the fact that it's negative. Do you know what the radius is? Now, the radius is always positive, right? Isn't it? Because it's a distance that we're measuring. Can you tell me that distance? It's X, right? Because the radius here is exactly the same as the distance that you go this way, then that would be X. So R here would actually be X. So do we know what X is? Well, it's negative X. Do we know what R is? It's X. Do we know what Y is? It's 0. Do we have all three? Yes, we can find all 6 trig functions. You see how this is a lot different than the previous examples? Okay, so let's try this. I'll list them out here. We said X was actually negative X. It's kind of weird. Y is just 0, and R is equal to X. So what would sine of theta be? Well, that was given, wasn't it? That was given? But you can actually see it from this. Sine was y over r, isn't it? So that would be 0 over x. 0 divided by anything is 0. What would cosine of theta be? That's x over r. So that would be negative x over x. What's negative x over x? Negative 1. What would tangent of theta be? It's y over x. So that's 0 over negative x. 0 divided by anything is 0. Yes. How come, which one is not negative x? Because r's, remember, r is always a positive number, right? So we have to make the connection that if we move to the left by, let's just say that that would have been negative 2, right? That we moved right here to the left. Let's just say this was the point, negative 2, 0. Then how far away are you from the origin? Well, 2 units, right? So we would use 2 instead of negative 2. But it's critical that you realize that the x-coordinate is negative. It's just the radius can't be. All right, cosecant. If we try cosecant, that would be r over y, right? R over y. R is x divided by y, which was 0. And division by 0 is not allowed, right? So we would say it is undefined. Undefined. Yeah, if you would rather use a number, then it'll always work out the same answers, because you're going to get 0, 1, negative 1, or undefined. That's what you'll get. As long as you're on, as long as it was sine was 0. Yeah. Everyone okay with undefined? That's the answer, undefined. All right, how about secant? The definition is r over x. R, though, in this case was x, wasn't it? Over x, which was negative x. See, it's weird, but it turns out to be negative 1. Or you could have just said the reciprocal of cosine, right? What's the reciprocal of negative 1? Flip it, still negative 1. And then how about cotangent? X over y, which is negative x over 0. It's undefined. So if you wanted to, instead of doing this, you could have just said, I'm going to do the reciprocal of 0. And if you look at 0 as being 0 over 1, if I tell you to flip this, what do you get? 1 over 0, and that's undefined. Either way you want to look at it, you get the same result. That was a little bit trickier, right, than the others? This will be our last one. Example, is it example 10? Yeah. Yes. Okay, say again. Is it always cosine? Mm-hmm. I think you answered your question very beginning. Only on the unit circle. The x-coordinate will always be cosine theta on the unit circle only. And then the y-coordinate will always be sine theta. That's what we're going to do right after this. Okay, so secant theta, I'm telling you, is undefined. And I'm telling you that the angle has to be between 0 and pi. Give me the other 6, or all 6 trig functions. If you see that secant theta is undefined, that means you have division by 0. Okay, that means when you're trying to find the secant, you're getting division by 0. So what was, well, I guess I should back up. Can I actually narrow down the quadrant? Well, I'm not even given that secant's positive or negative or anything, right? Just that it's undefined. I am given that my angle has to be between 0 and pi, right? Which puts me either in 1 or 2. So I can eliminate these, right? Just from this information. I'm not down there. What is secant by the definition? It's what over what? It's r over x, right? And what I know is that this is undefined, which forces what to happen? X has to be 0 then, right? This tells me for this to be undefined, that x there has to be 0. Do y'all see that? Critical point in this problem is to realize that. So come over here to your graph and tell me where your point would have to be for x to be 0. On the y-axis, right? Anywhere on the y-axis, right? X is 0 means you can't move left or right. You can only move up or down. Now, why can't I go down here? Well, we said our angle had to be between 0 and pi, so I have to go up. Now, let's try this one the way that, what was your name? Alicia, the way that Alicia suggested. Instead of actually calling that like some arbitrary value, let's give it a value. You can do this during the test if you like, if it helps you. I'm just going to pick a point up here. Everyone agrees there that the x-coordinate is 0? Yeah? And because I'm up, I just pick any y-coordinate, doesn't matter. So how about 2? Is that all right? Now, what's your radius? Because it's straight up and down, again, your radius here would be what? 2. And it just so happens it matches the positive 2 because the 2 for the y-coordinate, because we did go up, didn't we? If we had gone down, we would have put what? 0, negative 2 instead. But our radius still would have been 2. All right, so x here for us is 0, y for us is 2, and r for us is 2. And from that, you can get the rest, right? Get all 6 trig functions? So sine theta is y over r, is 1. Cosine theta is what? X over r, so 0 over 2, that's 0. Tangent theta is y over x, which is undefined. And then flip all these over for the rest. Cosecant theta is the reciprocal of 1, so 1. Secant theta is the reciprocal of 0. What did we say the reciprocal of 0 was? Undefined. And then cotangent. This one's kind of weird because there's 2 ways to look at this. You could say, what's the reciprocal of undefined? And then you're like, what the hell does that mean, right? Or you just look back at this and just flip that over. Flipping this over, you get what? 0 over 2? That's 0. So if you want, you can just kind of look at it as the reciprocal of 0 is undefined. The reciprocal of undefined is 0, if you want to. That pretty much covers the full spectrum of those types of problems, all right? Any questions then on any of the homework that pertain to this? 89 out of 74? Yes. It was cosine theta is negative 1/3, that one. So this is number 89 out of the homework. Cosine theta is negative 1/3. And they give you that the angle is between 180 and 270. Now, I'm still going to follow the same method that I did before. Try and narrow down the quadrant. I can actually narrow the quadrant down right away from this, can't I? But because I want you to get into the habit of really understanding what information this gives you, let me think about this first. If cosine is negative, we have to be where? Or where can't we be? Whichever way you want to look at it. So, all students take calculus. What's that? If cosine is negative, I have to be in the second or third, or in other words, I cannot be in the first and the fourth, right? So I cannot be here, cannot be here. But then they're telling me I have to be between 180 and 270, which forced me into the third quadrant to begin with, right? But I can tell you that on a test, I'm not going to force you into a quadrant like this. I'm going to give you something where this will give you two quadrants, this will give you two quadrants, and when you put those two ideas together, it leaves you with only one, just like I did in the first couple of examples. So I can eliminate this one. So we're somewhere in here. All right, so let me go back and look at this. Cosine theta, by the definition of cosine, it's the x over r, right? X over r. I know my r is always positive, isn't it? Yes? And that would mean my x had to be negative. Do you all agree that if I'm over here somewhere, if I need to get there, my x would have to be negative to get there? And then my y would also have to be negative, wouldn't it? But we'll get to that in a second. So I know that when I rewrite this fraction negative 1/3, I can actually force the negative sign. Whenever you have a fraction, you have a negative out front. The negative can go on top, or it can go on the bottom, or out front. Right? That's the way negative signs work. So because my x-coordinate needs to be negative, I'm going to put the negative up here on the 1, as opposed to down on the 3. What should I do now? I'll draw a little triangle here, here, like that. My x-coordinate's -1, and my radius is 3, which means I still need to find the y-coordinate, right? I still need to figure out, I know I go to the left 1, I know from here to here is 3, but I need to find this y-coordinate. So I use what to do that? The Pythagorean, right? X squared plus y squared equals r squared. So I'll write that down. X squared plus y squared is r squared. So x in this problem is -1. Square it plus y squared equals r squared, but r here is 3. So -1 squared is 1. 3 squared is 9. And to solve for y squared, we subtract 1 on both sides. So y squared is 8. And then take the square root, y equals square root of 8. Now, when I took the square root, I have to look at plus or minus, right? In the past, I just always used the plus. Why was I using the plus for the last few examples? Because it was the r, wasn't it? In all the problems that we did earlier today, every time we did this Pythagorean, it was always r we were solving for, which is always positive. But now, because of the quadrant, what must y be? Negative. So I'm actually going to take the negative root here because I'm in the third quadrant. So I'm going to put negative here because I'm in Q3. If I took the positive, where would I be? Would I be in quadrant 3 anymore? I'd be in quadrant 2, wouldn't I? If my y was positive, my x was negative. All right, so now let me list out what I have here. I have that x equals -1. I have that y equals -√8, which, by the way, is -2√2. That's what your book would, I'm sure, do. Right? They rewrite this as -√4 times 2, which is -√4 times √2, which becomes this. And then what's our R? Was it 3? Okay. Does that address the question? Yes? Do you want me to list out the 6, or you're good? Okay. Okay, I think we'll move into the next section, 7.5. The unit circle. So the unit circle, I think I told you a few times already. To me, as someone who teaches Calculus 1, I have students come in from pre-cal. I always ask them, the first day, like, how well do you know the unit circle? How intimate is your relationship between, you and that circle? Because the better that relationship is, the more comfortable you are with it, the easier calculus can be. Now, it's not going to be like guaranteed if you know the unit circle you're going to get through calculus, but you definitely have an easier time than if you have trouble with the unit circle. So if you have any questions throughout this, just ask me, all right? Stop me, try and clarify for you. All right, we're going to go 7.5.1. First thing is, what is a unit circle, right? Unit circle is any circle with radius 1 and we will center it at the origin. Now, when I say centered at the origin, that means the center of the circle is at 0, 0, the point 0, 0. So if you draw a unit circle, this thing has a real hard time drawing circles. Oh, it's not bad. Something like that. You don't have to be perfect, okay? There's my unit circle. Boy, it doesn't look like a unit circle, does it? The aspect ratio is different between my screen and what's up there. On my screen, it looks like a perfect circle. Up there, it looks like an egg. Doesn't it? Does it look off to you? I don't know, maybe it's the angle. Yeah, okay. So a circle centered at the origin, radius 1. Now the radius being 1 is the crucial element to the unit circle. And let me talk about, we're going to get into all the different cool things about this, but before we do it, let's first take some time to identify our common angles on this circle, all right? Now, the common angles that we talked about were, 30 degrees, 45 degrees, and 60 degrees, right? And then we said you could do that in radians also. So let me list out to the side here what are common ones. 30 degrees, 45 degrees, and 60 degrees. Now, in radians, what are those? What's 30 degrees in radians? Pi over 6. 45 is pi over 4, and then 60 degrees is pi over 3. Okay, so the way, when you draw a unit circle, you can draw these common angles around the circle, and we can go all the way around the circle with them. And let's start out with the degrees, and let's start with the 30. And let's keep in mind that when we do 30, aren't we also going to pick up 60? Isn't 60 a multiple of 30, right? So what I'm going to do is start counting around the circle. 30, 60, what will come next? 90, and so on and so forth. So we have 30 degrees, right? 60 degrees, and then straight up would be 90 degrees. Now, you're taking your time to do that, right? And you're realizing that maybe you didn't draw your circle big enough. So I printed one out for you to fill in. So before we get too far ahead of ourselves. I'll let you use this circle on the test, even though you have your own on your cheat sheet, right? Your cheat sheet has one of these. Do y'all see on your formula sheet that I provided you that it does have a unit circle in the top right-hand corner? Yep. But it's kind of hard to see it. Okay, so fill in 3690. Now keep in mind, we are also going to come in here, and next to the 30, I'm going to put pi over 3. And then I'm going to put over here, sorry, pi over 6. Dang it. And then on this one, I'm going to put pi over 3, right? So give yourself enough room to get the angles in there. And then what's 90 degrees? Pi over 2. Now, I said last class, do y'all remember this? That if you want to keep going around, you just keep on doing like 90, add 30, right? Add 30. Let's do that. Let's go all the way around with just the degrees, because most people have no problems adding 30 every single time. So the next angle would be what? In degrees? 120. The next one, 150, right? Then the next one, 180. Then 210, 240, 270. Three more. 300. Oh, I don't want it out there. 300, 330, and then all the way around is 360. Y'all okay with that? Now, how do you count in radians? This is what I was alluding to last class. Pi over 6, right? Pi over 6 is this right here. Then the next one, right? This next one is another pi over 6. So I told you to look at that as being 2 pi over 6. I would not write this down on your circle, okay? Write it down on side note. The next one, when I go straight up, would be what? How many pi over 6s? 3 pi over 6s. The next one would be what? 4 pi over 6s. The next one, 5 pi over 6s. The next one, 6 pi over 6s. Then 7 pi over 6. Then 8 pi over 6. Then 9 pi over 6. Then 10 pi over 6. Then 11 pi over 6. And then 12 pi over 6. Do y'all follow how I did that? Counting around by pi over 6 the whole way? Then you go back, and any fraction that reduces, reduce it. So which of these fractions reduce? The 2 pi over 6 reduces to be what? Pi over 3, right? 2 goes into both the 2 and the 6, so that's pi over 3. So that's what you should label your unit circle, pi over 3. And then this one, what's 3 pi over 6? That's really just pi over 2, because 3 goes into both. And then 4 pi over 6, does that reduce? Yes, 2 pi over 3. Does 5 pi over 6 reduce? No, so that's actually the one you're going to use, right? 5 pi over 6 there. Does 6 pi over 6 reduce? To pi. Does 7 pi over 6 reduce? No, leave it like that. 8 pi over 6? Yes. 4 pi over 3, right? How about 9 pi over 6? 3 pi over 2. Do y'all understand what I'm doing here? Yes? The next one, 10 pi over 6 should be 5 pi over 3, so reduce that one. Does 11 pi over 6 reduce? No, that's this. And then 12 pi over 6 is 2 pi. So all the ones that I've circled are the ones that you would have to change and put on your unit circle. The ones that are boxed should be exactly what's on your unit circle. Are we good? You have one what? Oh, I'm sorry. Is there an extra anywhere? Yes. Got a couple. Did I not give you one? Or what happened? Sorry about that. If you're going to take anything away from what I just did, okay, is the ability to count your way around the unit circle with the radians. Because if you try and sit here and memorize, okay, yeah, that one was 5 pi. If you try and memorize it that way, it can be very challenging. If instead you're here and you say, okay, I need to count by pi over 6s. That's 1 of them, 2 of them, 3 of them, 4 of them. That's 5 pi over 6. It's much easier, I think, to do it that way. Now, some people's brains work a little different, and they're like photographic memories, and they can just memorize the circle, and they don't need to do that. For me, it didn't work. So I have to count. Okay, now that just took care of your 30 and 60 degrees, right? What about the 45s? Well, since I've got such a cluster here, I like to just start over. Now, you can't because your circle's there, but you got a nice big circle. 45 degrees is there, then straight up, then here, then straight over, then here, then straight down, then here, and then straight over, right? So that's 45. So you can count by 45s around. Start out at 0, then 45 degrees, then 90 degrees, then what? 135, then 180, then 225, then 270, then what? 315, and then your 360. So again, I think it's easy for most people to count around the degrees. Let's now count around in radians. So what's that first slice? This right here is, you have to remember that one. That's pi over 4. That one you've got to put in your memory bank. So this is pi over 4. Can you reduce that? No. Count to the next one. The next one is straight up and down, right? How many pi over 4s is that? 2 of them? Can you reduce that? That's going to be pi over 2, isn't it? Which we already had on our circle. The next one here is how many pi over 4s? 3 of them. And then 4 pi over 4. Then 5 pi over 4. Then 6 pi over 4. Then 7 pi over 4. Then 8 pi over 4. I will highlight the ones that need to reduce. You got to reduce that, reduce that, reduce that, and reduce that. Which, didn't we already have those? When we did the 30s, the 30 and 60s, we already had those, didn't we? The ones in yellow? So these are the only ones that are new, and they don't reduce, those like 4 corners. Do you have any questions on how to create all of the common angles on the unit circle? If I gave you a quiz next class, walk in, blank unit circle, take everything off your page, do you think you could label all these angles? All right, well, that's a question you need to ask yourself. And I would say you should probably be prepared for that sort of quiz for next class. Because it's not about memorizing the circle as much as it's about understanding it and being able to construct it, you know? During a test, you'll always be able to reference the unit circle. But you don't want to get into a habit of always breaking that out. You want to have some knowledge of where it comes from. We good? All we've done is created the angles. All right, that's all we've done so far. Those are the common angles on the unit circle. Now, 752. Points on the unit circle. So you can keep your unit circle out because we're going to keep drawing, we're going to keep writing on it, okay? The one that I had you draw the angles. There are some points on here that should be pretty easy for us to figure out, specifically the ones that are on the x and y axes. So like this point right here, can you tell me what the x and y coordinates are of that point? And then support your answer with why it would be that way. What's the x coordinate? What's the y coordinate? 1, 0? Okay, I think most people would be okay maybe with understanding why that the y coordinate is 0. Everyone okay with that? Because you don't go up or down to get to that point. But why is the x coordinate 1? It's a unit circle, isn't it? That's the unit circle, so the radius is 1. And so the distance from here to here is the radius, isn't it? So it has to be 1. Do y'all follow that? Now, if I did not tell you this was a unit circle, if I told you this was just some arbitrary circle, you wouldn't know that. You wouldn't know it's 1. And you would have to just say, I don't know, it's x. I don't know what that is. But because it's the unit circle, you're guaranteed that's 1. With that same logic, what's the point up here? 0, 1, right? Instead of 1, 0, it's 0, 1. And then what's the point over here? Negative 1, 0. This time, to get to that point, you have to move to the left 1. Go ahead and label these on that circle I gave you. And I'd put them on the outside of the circle like I did there. Just give yourself room because we have a lot of other points we're going to be filling in here. And then straight down, which point is that? 0, negative 1. All right? All right, now, let's just go to the first quadrant, okay? Just the first quadrant. Let's put the common angles. Well, you already have it drawn, but I'm going to focus all my attention on the common angles in the first quadrant. They were 30 degrees, 45 degrees, and 60 degrees. In each one of those, there is a point on the unit circle, right? Each one of those. I'm going to tell you what each one of those are, and you need to memorize these, all right? For the first quadrant, it's the only quadrant you have to memorize. This one right here is square root of 3 over 2, 1/2. Do those look familiar? When we were first talking about the values of the trig functions at the common angles, didn't root 3 over 2 and 1/2 pop up every once in a while? Didn't they? You remember those? Like if I would have told you it was like square root of 5 over 4 and like 1/3, those would be like numbers you haven't seen, right? These you've seen a lot of. Okay, the next point at the 45 degree mark, x coordinate is root 2 over 2, y coordinate is exactly the same. Does that make sense that that would be true? 45 degrees, which however far you go out is the same distance you go up. And again, you just have to memorize that it's root 2 over 2, root 2 over 2. And then this last point, which is the 60, is 1/2 root 3 over 2. Does that look familiar? Yeah, it's the same thing that we had for the 30 degrees, isn't it? Just change the x and y coordinate. If you can memorize these 3 points right here, then we should be able to construct the rest of the unit circle without having to think too much about it. Now, I always had relatively an easy time remembering that the 45 was root 2 over 2 because you can't get that wrong, right? I mean, you can't accidentally flip it backwards. It's root 2 over 2, root 2 over 2. It doesn't matter which way you go. The 30 and the 60 is the one I used to have trouble with until I realized that there's kind of an easy way to remember it. Does anybody kind of have a way that they think they could remember that this one is the root 3 over 2, 1/2, and this one's the other way around? Think about it this is the way it made sense to me. If both of these right here have the same denominator, right, 2 and 2, then look at the numerators, root 3 and 1. What number is bigger, root 3 or 1? Root 3? The square root of 3 has to be bigger than 1, doesn't it? Do you all agree? The square root of 3 is bigger than 1? So doesn't that mean that the x-coordinate is bigger than the y-coordinate? Wouldn't this mean if the root 3 is bigger than the 1, then this coordinate, the x-coordinate, has to be bigger than y? Now look at your point. If you looked at it like a little triangle, to get out to this point, don't you have to go further along the x than you have to go up and down? That's the way I remembered it, is that the x has to be bigger than the y for this point. Look at this one over here. To get to that point, I'll exaggerate the triangle here. To get to that point, I go out a little bit of x, right, and then I go up a long way. There, the y-coordinate has to be bigger than the x-coordinate. So it's the other way around. Does that make sense? If you want to memorize a different way, go ahead. But that's the way that I kind of rationalized it in my brain when I was trying to learn this. All right, now let's get all the other points along the circle. So what I'd like to look at now is this first point on this side right here, which is 130, or in radians it's 4 pi over 6, which is 2 pi over 3. Okay. Either way you look at it, degrees or radians, make sure you can now look at your circle or count it out, however you want to do it. And tell me what the difference is between this point here and this point here. What's the only difference? The x is negative, right? Do you agree that they're the same height? So if they're the same height, they have the same y values. Yes? So what I can say is that if I take this point right here and mirror it over the other side, the only thing that changes is the x-coordinate, and it becomes negative. So this should be negative 1/2, but then still stay positive root 3 over 2. Do y'all see that? I'm just mirroring it over. And I can do the same thing for this point right here. If I mirror it over to the other side, that's not a very good drawing. That's my 3 pi over 4, isn't it? That's 3 pi over 4. And so the coordinates on that point are what? Only thing that changes is the x becomes negative, root 2 over 2, and then positive root 2 over 2. And then we keep going. For this point here, I'm mirroring over this point. So the x changes, the y stays the same. How do you think I can get the third quadrant? How about we mirror these down now? Like take this point right here, mirror it down, it would be this angle right here, wouldn't it? These points. Do y'all notice that the x-coordinates here do not change? What changes though? The y becomes negative. So this point should be what? Negative root 3 over 2, but then negative 1/2. And then go to the next angle, which would be this one mirrored down. What's that? Negative root 2 over 2, negative root 2 over 2 again, right? And then we could keep going. Negative 1/2, negative root 3 over 2. You see that it's still all the same numbers. It's always root 3 over 2 and 1/2 or root 2 over 2. It's always one of those three numbers. And it's just a matter of which sign and which order it is. Now, the fourth quadrant, I could mirror these over, or you could bring the first quadrant down. It's up to you. I'm going to bring the first quadrant down. I'm going to bring this first point here. I'm going to bring it down to here. And realize that when I come from this point here down, The only thing that changes is the y-coordinate. The x-coordinate stays the same. So I'm still going to have root 3 over 2, but that's going to become negative. So root 3 over 2, then negative 1/2. The next point down, root 2 over 2, negative root 2 over 2. And then the last one is 1/2, negative root 3 over 2. Now that should be, now that you have it all put together, that should actually be exactly what you have on the top right-hand corner of your cheat sheet. Do y'all see that? I would practice this. Okay, I would just go Google blank unit circle and go print off a few copies and see if you can draw your unit circle without any reference to any notes or anything. Just see if you can draw it out of your own mind. All right? On your test, I'm not going to give you a blank unit circle and say, fill in the unit circle. I won't give you that. But I want you to at least, for some period of time, maybe just by next class, at one point in your life, you're able to draw the unit circle without any help. And then once you can do that, then we can move forward. Does that sound fair? Okay. All right, now, what is the value of the unit circle? Drawing it's one thing, but what does it give us? And this is the key to everything. Yes? Uh-huh. Everything. I would hand you exactly what I handed you, like this. I'd say fill it completely out. All angles, label all angles in both degrees and radians, and label all points. So that should take you like, what, 2 minutes, 3 minutes? I'm kidding. So it'll take a little while, but you want to, So do y'all see that really it is just the first quadrant is the only thing you really have to remember? And then just change signs as you move around? I would not encourage you to just try and memorize this. The whole thing. All right, so what is the value of the unit circle? What is it going to give us? So I would like for us to look at our first example. I would like for us to take a look at what is sine of 5 pi over 6? Well, let's look at our unit circle. Where's 5 pi over 6? How about right here, isn't it? Yes? Now, sine by definition, sine of an angle is the y-coordinate divided by the radius, isn't it? Do y'all agree? But if we're on the unit circle, what is the radius? 1, right? Which means that sine of an angle is just going to be the y-coordinate, isn't it? Well, look at your unit circle. What was the point that was out here for this? It was negative root 3 over 2, and then 1/2. What's the y-coordinate? 1/2, right? So sine of 5 pi over 6 is just 1/2. It's just the y-coordinate. Y'all understand? What about this? What's cosine of 5 pi over 6? Well, again, because we're looking at the unit circle, right? Cosine of an angle is always x over r. But because our radius is 1, it's just x, isn't it? So go here and take a look. What's your x-coordinate at 5 pi over 6? Negative root 3 over 2. So you might be sitting there saying to yourself, do you mean to tell me that in order for me to figure out what the trig function is, all I need to do is be able to read the unit circle and pick out the x and y coordinates? And my answer is yes, that is the point. That is the whole value of the unit circle. Is that if I say what is cosine of something, and it's one of your common angles, you should just be able to go to your unit circle and pick off either the x or the y coordinate. Well, if I say cosine, the x coordinate. That's it. Let's try another one here. As an example, find sine of 270 degrees. So real quick, somebody who's kind of catching this, tell me what you're going to look for here. The y coordinate, because it's sine, right? The y coordinate at what angle? 270. So go to your unit circle, go to 270. What's your y coordinate? What is it? -1. So what I did is I went to my unit circle. I looked down at 270 degrees, which is this point. That's the point 0, -1. And because it's sine, I'm picking the y coordinate. Questions? What is tangent of 270? Well, what's the definition of tangent? It's y over x, isn't it? Tangent of an angle is y over x, which means that in order to figure out tangent, you can't just look at one of the coordinates. You actually have to look at them both, right? And you have to take the y coordinate mentally and divide it by the x coordinate. What's y divided by x? What's -1 divided by 0? Undefined. Undefined. This is -1 over 0. This is undefined. Are we all right? This is a big deal, okay? Because even to this day, all right, and I've been doing this for my whole life, basically, doing math, seems like. Even to this day, if somebody asks me, you know, what is sine of 7 pi over 6? In my head, I just saw 7 pi over 6 as being down there in the third quadrant. Sine is the y coordinate, so I think, okay, over there, the x is bigger than the y, -1/2. I mean, in my mind, I'm seeing the unit circle. I don't have these memorized. That's the way that a good mathematician uses the unit circle, to pick these angles off mentally. Does that make sense, what I'm saying? I don't know, it might take you a while to get to that point, but you definitely don't want to be like getting to Cal 1 and they're like, what's cosine of 0? And they're like, you know, you're going to your backpack. Hold up, I'll get my calculator, okay? Because what's cosine of 0, everyone? Cosine of 0 degrees, where are you? Where's your angle? 0 is directly to the right. That's right here. That's the point 10, right? Cosine is which one of those numbers? The x, right? The 1. So cosine of 0 is 1. What's sine of 0? Is the other coordinate, right? So cosine of 0 is 1, sine of 0 is 0. Now things can get a little messy. Let's take a look. What if you have something like, what's sine of -13 pi over 6? So there, you have a couple of options here. You could try and figure out a coterminal angle. Remember we said every angle, you can come up with a coterminal angle? We did that at, like, not last class, I think it was a class before. You could do that, right? And but to do that, you just like add or subtract full rotations. Do you all remember us doing that? I'll show you how to do that problem that way, but I'll show you how I would do it, all right? This is how I would do it. Now again, I would have my unit circle sitting right next to me. And I would notice that this is really 13 pi over 6s, right? And it's negative, which means my rotation should go clockwise, right? So I'm going to start counting out 13 pi over 6s. There's 1 pi over 6, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So this is really where I am. Do y'all see that? What point is that on my unit circle? That's the point root 3 over 2, negative 1/2, isn't it? When I was counting the pi over 6s, I was not counting the 45 degrees in there, right? I was skipping over those when I was counting. My 45s are in here. You just have to be a little careful with that. Your 45s are in there, but you're not counting those when you're doing the pi over 6. Understand what I'm saying? So do you all agree that that's the point I'd be at negative 13 pi over 6? And now we wanted sine to the y coordinate, which is what? Negative 1/2, and I'm done. Now let me show you how to do it the coterminal way. This way would have been a little harder. What I would have done is I would have taken negative 13 pi over 6 and tried to find a coterminal angle. And because it's negative, what I'm going to do is add a full rotation. Negative 2 pi. Or sorry, add 2 pi. So I have to get a common denominator, which would be, what, 12 pi over 6? And then when you add those two together, you go negative 13 plus 12 is negative 1, so negative pi over 6. And I think you can kind of tell from negative pi over 6, you would just go down like that. You just go clockwise pi over 6, and we would be exactly where we were, right? Which way do you think was easier? You're not going to hurt my feelings. If you like this way, coterminal way, do it that way, or counting, right? I personally think the counting was faster. All right, how about this? What about, we haven't done this yet, tangent of 390. Let's make it, 390. What's tangent of 390 degrees? Well, 390 is very close to what? 360. In fact, 390 is actually 30 more than 360. So if I go to my unit circle, 360 is all the way around. Then I add another 30 degrees. So I'm really looking at a 30-degree mark, right? I'm looking at that point, and that point is the point root 3 over 2, 1/2. Tangent, we said, was which one divided by which one? It's the y over the x. So this would be the 1/2 divided by the root 3 over 2. And now you can't leave your answer like that. You have to clean that up. So we flip the fraction multiplied by the reciprocal. So 1/2 times 2 over root 3. The 2's will cancel out there. And you'll be left with 1 over root 3. And rationalizing the denominator, you get root 3 over 3. Now I'm going to take it all the way to root 3 over 3 because this is going to come up later. You need to be able to look at that and recognize it. All right, like, oh, root 3 over 3, that comes when I'm doing like tangent sometimes, right? Because remember, I said that these two numbers come up all the time, right, on the unit circle. They're all over the place. So anytime we have to divide one of them by the other, like that, we're going to get, that could come out quite a few times, couldn't it? So let's start to recognize root 3 over 3 as one of our common trig values. Do y'all think that y'all understand this? Anyone feel uncomfortable with it? All right. Take a look at, make sure I've covered what I want here. Just going to pull one of these uglier problems here. How about this as our last example here? I stopped labeling. That was example 4. So this is example 5. Find the exact value of cosine negative 17 pi over 4 minus sine of negative 3 pi over 2 plus secant of pi over 4. This is basically 3 problems in one. So let's see how quickly we can knock out these values. Now, also, I'll point something out. When I say exact value, right, that means you cannot give me a decimal answer. Your answers have to have square roots and all that stuff has to be in there. All right, so let's look at our first one here. Cosine 17 pi over 4. So how would you do that? Coterminal or count? I'm just trying to get a feel for what the class thinks they would do. Think you count? Yeah? Okay. So let's see. Y'all see if y'all can do this one. I want to see where you are with this. See if you can come up at least with each 3 individually, and then we'll work on trying to put them together. And raise your hand if you have any questions. I'll come by and help out. Does anybody need a formula sheet? Everyone has one? You know? Okay. So unit circles there in the top right. I'm going to call attendance. I already checked some people earlier, so if I don't call you, I probably already did. Alicia? Okay. Arya? Okay. Ariane? Is that pronounced okay? All right. Donata? I'm going to start working through this one, okay? Negative 17 pi over 4 means I need to look at the pi over 4 increments, and I need to go clockwise. I need to count 17 of them. So I'm going to go, starting at 0, I go 1, then 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So I should be down here. Who else got that? Down there? Yes? And so I have the point there is root 2 over 2, negative root 2 over 2. And I'm looking at cosine, which is the x-coordinate. So I know that this right here is root 2 over 2. Yes? Anyone have a question on that? I counted out. Are you having trouble counting because the 30s, 60s are getting in the way and confusing you? I mean, that you just have to get used to. Make sure you're skipping over those. Okay, what about negative 3 pi over 2? Well, what's positive 3 pi over 2? Positive 3 pi over 2 is here, isn't it? Isn't that positive 3 pi over 2? But you need to do that same rotation backwards. So if you do that same rotation backwards, it takes you there. Now you could, if you wanted to, I wouldn't advise this, I would advise doing it the way I just showed you. You could convert that to negative 6 pi over 4. In other words, you know how to rotate by pi over 4s, right? So you could kind of unreduce it and put a 4 on the bottom by multiplying top and bottom by 2 here. And now count backwards 6 pi over 4s, which would have done 1, pi over 4 is here. You would have done 1, 2, 3, 4, 5, 6, and you would have been in the same place. So either way, is that all right or not? Okay, what's the point here? 0, 1, and I'm looking for the y-coordinate. So this one will be 1. And then secant of 5 pi over 4. So I go to my unit circle, I count by pi over 4s, and I'm counting clockwise this time, right? 5 of them. 1, 2, 3, 4, 5. So I'm down here. What are the points here? Negative root 2 over 2. Root 2 over 2? Negative. Thank you. So they're both negative. And which one am I grabbing? Well, secant, right? Secant is the reciprocal of cosine. Which one of those is cosine? The x-coordinate. But I need the reciprocal of it. So instead of negative root 2 over 2, I can use 2 over root 2 instead. See how that works? So I'm using this, but I'm flipping it. All right, so let's put it all together. The first one we said was root 2 over 2. So this is our final answer, root 2 over 2. Then minus the sine one, which was 1. And then plus, it was 2 over negative root 2. Yeah? Now that would be an exact answer, but let me just clean it up a little bit. Did I tell y'all about my other class, like one of the first days of class, where one of my students, this girl came in wearing a Cowboys like jersey? Did I tell y'all about that? And I was like giving her a hard time about it. Like, you're still wearing that? You know, like ragging on her. And hope y'all have a good season. Ha ha ha. And I don't know. Now I can't face her. I feel bad. This would be okay with me on a test. All right. The book most likely would try and get a common denominator between all these. So let me just show you what you would do. Here, I would rationalize. So I get root 2 over 2 minus 1, and then here, 2 root 2 over what? 2. Now, I agree these 2's would cancel. However, I'm going to try and put all these together. So I'm going to need a 2 on the top and bottom of a 1, so I'll make the 1 will become a 2 over 2. So it becomes something like this, root 2 over 2 minus 2 over 2 minus 2 root 2 over 2. So I just got a common denominator between all of these. And now I put all the numerators together. Root 2 minus 2 minus 2 root 2, all of it over 2. Does anyone see what we can still do here? In the numerator? Root 2, take away 2 of them, is like having like 2 apples and taking, I mean, an apple and taking away 2 apples, right? So you should just be left with negative 1. So this, I'm out of room, I can't go any further. This should be equal to negative 2 minus a single root 2 all over 2. So like if you looked in the back of the book, that's the answer they would have, and you might be going, whoa, how did that happen? Well, that's how that happened. All right, we only have 15 minutes. What I'd like to do is give you your homework assignment, and then I'd like to introduce you to the next section, because I'd like to kind of plant the seed and let you start thinking about this. Because I think from here on is where the course starts to really take on its challenge for students, all right? But this is the essential. You get this down, it makes what we're going to do a little easier. All right, page 559. You should take a look at 9, 11, 15, 17, 21, my goodness, 21 through 35, odds there. And then 55, 57, 59. Let's do those. Now, just so you know, in case you are going to tutoring or something like that, getting help, there are things in this section I have not covered that I'm going to cover in the next section, because I think they're more natural to talk about in the next section than they are right now. All right? So just be aware of that. All right, let's start 7, 6, 7, 5. What the heck is it? Wait a minute. Hold on a second. Did I just give you the wrong? No, I gave you the right page. 559. We're 7, 6. So let's just begin the discussion here. Graphs of sine and cosine functions. Okay, we are going to start taking a look at graphs of functions. Specifically, we're going to start with the 2 common trig functions, sine and cosine. But I want us to remember just some basic ideas with functions. Something like f of x equals x squared plus 1. When we had something like this, hopefully everyone here recognizes what that would look like, right? You know what? Let's make it minus 1 instead of plus 1. Hope you're writing in pencil. Right. Do y'all know what this looks like if I were to ask you to graph it? X squared minus 1. Parabola. Opens which way? Up. And then the minus 1 did what to it? Moved it down 1, right? So if you were to graph this, it would look like this. Go like that. Right? That's what it would be. Now, the way we got it back in the day, before we actually understood what quadratics were doing, is we had this idea of having like f or x and f of x. We'd do like a t-table. We'd plug in some values, right? So like for x, which would be we had on our graph, we had our x-axis, right? And then this was our y-axis, which was the f of x. We would plug in a value like 0. We plug 0 into the function. 0 squared minus 1 gives us negative 1, right? Then we would plug in, let's say 1. Plug in 1 squared minus 1, that gave us 0. You plug in 2, you get 2 squared, that's 4. Take away 1, it's 3, right? So then what you do is you would plot these like points. You go 0, negative 1, 1, 0, 2, 3. And then you come over here and put those on your graph. Here's 0, 1, negative 1, sorry. Here's 1, 0. And then 2, 3 would be way up here, wouldn't it? Something like that? Put these points together and you get the feel of what the picture looks like, right? Yes? All right, now, if I had changed the problem, and I had made it, if I had come in here and say to you, look, everyone, graph f of theta equals theta squared minus 1. It's the exact same graph, isn't it? Isn't it? Except instead of using x, I'm using what? Theta. So theta is like the dummy variable. X is called the dummy variable. We can call it x, we could have called it m, we could have called it t, we could have called it theta. If we graph it, the only difference in the graph is that instead of having the x-axis, we would call it the what? The theta axis, and then up here would be f of theta. And then we would still make our little t-table, we'd do our business, and we'd still come up with the same parabola, wouldn't we? Same exact thing, but we would get it by getting points. Plugging in values of theta, and then getting out a return, an input and an output, and then we would graph that as a point, yes? So the general idea for the function is that we had, I'm going to still use, let's say, theta. We have a domain, which is the input. It goes through the function, f, and comes out, right, the output, which is called the range of the function. Do you remember this concept for a function? Plug something in, it spits something out. All the things that you can plug in are called the domain. All the things that come out give you the range. So for this quadratic function that we have up above, what's the domain of this? What are you allowed to plug in? All real numbers, right? You could always square something and subtract 1. Now, how could you tell that the domain of this is everything from the graph? You look at the x values, you say this graph goes up and out forever, right? So for every x value, there's some graph somewhere, right? There's nothing missing and it doesn't stop. We'll talk more about this, don't worry. How do we say all real numbers for domain? Yeah, you can do this, negative infinity to infinity, or you could have put like that, what we call double struck R, all real numbers. What's the range of this function, though? What comes out of it? Now, that's your y values, right? Does negative 10 ever come out of this function? No. Does negative 5 come out? Does negative 1 come out? Yes. Does 0 come out? 1, 2, 3. So everything from negative 1 all the way up, right? So we would go and say everything from negative 1 to all the way up forever? Infinity, like that. Does this kind of ring a bell a little bit? I'm trying to get you to pull some of the ideas out from college algebra that we're about to use. Okay, we only have 5 minutes, so all I'm going to be able to do is show you one thing. What I'd like for us to do, 7.62, is I would like for us to define a new function f of theta to be equal to sine of theta. Which means if it's a function, I could come up with a table, couldn't I? I could plug in theta and figure out what comes out. So let's plug some things in. Now theta is an angle, isn't it? So what is sine of 0? So you go to your unit circle right now, right? You go to the angle 0, and you tell me which coordinate? If we're doing sine, which coordinate on your unit circle are we looking at? The y coordinate. So what's the y coordinate at a 0 angle? 0. Okay, now I can't just plug in random numbers here. What about 30 degrees? What's sine of 30 degrees? 1/2, right? How about 45 degrees? What's sine of 45? Root 2 over 2. And I could keep doing this, couldn't I? I can start filling out my table. I can start drawing a picture. Do you agree? So I wrote some code that I think will help you, hopefully, see this. Okay. I have two pictures here. On the top is the unit circle, all right? The way that now it's not filled out, but that's our unit circle. That's just the idea in the background. This right here is what I messed up my axis. This should say sine, this should be theta, sorry, and this should say sine theta. Oh well, it's okay. So this is like our theta axis, right? And this is f of theta. That's our function. You said that when we went to 0, right? When we were at 0, we got 0, right? So now up there, what I'd like to do at pi over 6, right? Pi over 6 was 30 degrees. You got 1/2. So if I move to the right pi over 6, I go up 1/2 and I put a point there, don't I? All right. And then I move over, let's say pi over 4 was here. So I move over pi over 4. It's root 2 over 2, which if you did it on your calculator is like, you know, it's like bigger than 0.5 but less than 1. So do you see I'm putting the points here? They're really small. They didn't come out very big. You see that point, that point, that point? Yes? And I keep doing this. Let's go to pi over 6. We're up there at root 3 over 2. And then keep going around the circle. You see as I go around, like, look, we got to the top right up here. And that was the biggest we're ever going to be, right? At sine of pi over 2, we're way up at 1. But as soon as I get past pi over 2, what's going to happen to that y coordinate? It's going to start going down. You see, we're taking this measurement right here, and that's this measurement from here to here. This right here on this x-axis is actually measuring this angle. And I keep going. Now my my y coordinate's getting smaller and smaller and smaller, and then eventually my y coordinate now is going to do what? It's going to get negative. So now my graph's going down that way. And then I get to the very bottom right there. My y coordinate is actually what there? -1. And then as I come back around, it's now going to get smaller and approach 0. Yes? So this graph right here represents what's happening to sine as I go around the circle one time. If I keep going, isn't just going to repeat that pattern again and again and again and again, right? So what I can do here is I can bring in, if you were to fill in all the different points in there, everything, that's your graph. And so that's the graph of sine. Does that make sense? What we are going to do is study that graph a little bit more. Like there's a sine function. Then what we'll do is we'll change it so that maybe it doesn't have to be between 1 and -1. We'll change that. We call the amplitude. Then we'll change the period. So we'll squash it in here and, you know, mess with it. And we'll figure out how to graph different versions of sine. And we'll do the same thing for cosine. And we'll do the same thing for tangent. And we'll do the same thing for cosecant. And then we'll do the same thing for secant. And we'll do the same thing for cotangent. And we're gonna be able to graph all these by hand at some point in time. All right, so that's where we're headed. Y'all have a good day. Make sure you do your homework.